Hello first-time coders. So today we want to see how to nest loops. What's the effect that we are going to get if we put one loop inside the other? This is very important if we want to repeat the same process several times, while that process itself is consists of repetitions of some tasks. So let's get to it. Let's have a look at a simple for loop that starts with a value of 1 and stops at 6. In the beginning, it will allow you to enter the for loop. It will assign you a value of 1 and it allows you in. You start executing the code within the loop. When you reach the end of the loop, you cannot go out because you have not reached the stop value. Rather, your value is increased by 1. Then you go back and run the code again that is within the for loop, and when you reach the end, your value is incremented again, and this will continue until you reach the stop value. Then the door at the bottom will allow you to pass. So what happens when we put another for loop inside the existing for loop? Well, when you come to the beginning of the for loop, the upper door will open and I will be assigned the value of 1. Then you will be able to enter into the for loop. You will print I in line 2. When you reach line 3, you reach another for loop. Since we have a variable for it, then the value of the variable will be initialized to 1 and the upper door for that for loop will open. Now we are inside the inner for loop. We will print j, but now we are trapped inside the inner loop. We cannot go out neither from the top nor from the bottom. We can only go out from the bottom when we are in the loop, but the door from the bottom will only open when j is 6. So j is incremented by 1. Then we go back to the top of the for loop. Now when we go back to the top, we print j again, we come to the bottom, it increments us by 1. Now we are 3. We go back to the top, we print j, now j is 4. We go back to the top, we print j, now j is 5. We go back to the top, we print j, now j is 6. So the door will automatically open. We don't have to go back to the top again, and we come out. Immediately we come out, we find print in line 5. We execute the print in line 5, but we cannot go out from the outer door because the I value is still 1. The I value must reach 6 before we can go out of the outer loop. Therefore, we have to increment I first, then we go back to the top of the outer loop. Now we print I. I is 2. Then we encounter the for loop again. So now j is reinitialized to 1. And then we enter into the for loop where we are trapped again until we finish with the inner for loop before we can come out and then increment I again. And this will continue until I is also 6 before we can go out of the outer for loop. So all for loops behave in a similar manner. The inner for loop runs faster than the outer for loop. This is because the inner loop must finish iterating before the outer loop iterates once. Another thing to keep in mind is that in the first time you enter the for loop, you have the value of I, and that value of I is what keeps changing. So whenever you need to access different positions of a list, or you want to multiply numbers that are increasing by 1 by another number, so it is I that you need. However, j is not present at the time because we have not reached j yet. But once we enter j, now we have the value of j. Another thing you should be careful about is that once you come out at the bottom, j is 6. So if you want to use the value of j, you are free to use the value of j at the bottom here. But you should remember that the value of j is 6. So that value of j will be maintained until we enter the for loop for the second time. So you should also know that you can combine different types of loops. You can have an outer while loop with an inner for loop, an inner for loop with an outer while loop, a while loop with a while loop, and a for loop with a for loop, as we have seen. Nothing changes in the behavior. It remains the fact that the inner for loop iterates faster than the outer for loop. Let's try our hands on another example. Let's say you are asked to write a code for the fuel dispenser so that as the fuel is going in, the loops will count the price. So we will use A, B, and C as our variables that will store the digits of the price as shown in the screen. So as you can see, we have A, B, and C, each representing the digit down below. We know that when C reaches 9, it goes back to 0 and B increases by 1. And when B reaches 9, it goes back to 0 and A increases by 1. Here is the catch. A has no bound, which means A will keep on going as long as B keeps on reaching 9. So for A, we have no option but to use a while loop. So use while loop for A. This is just a comment. But for B and C, we know that they will always reach 9. Whenever they reach 9, they go back to 0. So they are bounded, and we know what is the maximum value they can reach. So we will use for loop for B and C. Okay. Now, if you look carefully at the video, you would notice that C is the one that is changing faster than B, and B is the one that is changing faster than A, which means C is the one inside. So we'll just say for C in range 0 to 10. Remember, the for loop will not count the last digit. So for this, we'll just print A dot, then B, then C. Oops. So here we'll have A, B, and C as our digits. So then we go outside to do the slower for loop, which is for B. So we can just push this inside. We said we will use a while loop for it. So we have to initialize A outside, then create the while loop. Okay, so the issue here is we don't know when A will stop. So let's give it 99, or yeah, 999. Then it will stop. Okay, So which means we can still use a for loop for it. But if we have something that is counting the fuel for us, like a sensor, then we'll keep using the value for the sensor while the sensor of the nozzle stops. So we'll use the logic here that while the nozzle stops, we exit the for loop. In this case, we don't have a nozzle, so I just think of a number from my head. So after we get out of all these two for loops, then we increase A by 1. So this loop changes very fast, and then this moves once. When this reaches 9, then the outer loop prints 1. So let's run this. So you can see the numbers will keep increasing until we reach 999. Okay, so what else can we do? Much numbers are A, sorry. And this is C, this is B. Okay, so this should prevent it from going to next line. Okay, so good. Everything now is on the same line. Okay, now we want it to clean the previous work and do a new one. So we'll use carriage return \r. Okay, let's slow down the speed. Okay, let's say, all right, let's import time so that it slows down the speed of the simulation. So we can just say, okay, sleep for 1 second. Time.sleep. So let's run this. So you can see the counter is running in one place. The carriage return makes the end, make sure we are printing on the same line. The carriage return makes sure we go back to the beginning of the line and write on the old code. Thank you for watching and see you next time.